Hi, welcome to Statistics 1, Lab 7. The goals of this week's lab are to conduct moderation and mediation analyses. And you'll see this lab is a little different from previous weeks in that I'm separating it into two segments. It's still just one lab video file, but we'll read in two separate data sets to keep things straight. So in the first one, we'll do moderation analysis. And in that example, it's just the one from the lecture where we're looking at the effects of stereotype threat on intelligence testing. So the dependent variable is a score on an intelligence test. And notice I'm using the phrase dependent variable here because this is an experiment. There was a manipulation of stereotype threat. So the dependent variable y is the outcome variable. The independent variable x was the treatment. That is, which level of stereotype threat or control was the subject randomly assigned to. So in this experiment, or in this example, there's control, explicit threat, and implicit threat. The moderator variable in the example is a score on a working memory task. And there's a total of 150 people with 50 in each condition. In the second segment, I'll read in a different data file, and we'll do mediation analysis. Using the same kind of setup, except here we'll use working memory as a mediator variable. So that's why I'm using two different data sets, just to keep this keep it less confusing. So we have one data set for moderation and a separate one for mediation. So again, I've commented out these first few lines of code where you need to just make sure you're in the right working directory and also install packages. You'll probably need to install this new one called multi-level. So I'll start here where I want to load the packages, and I'll read in the first data file for moderation analysis, and we'll take a look at it using the edit function. So here are the data, and these are the data that we used to illustrate moderation in the lecture. So you see there's a condition variable, control, threat 1, threat 2, score on an IQ task, score on a working memory task. And to save time, I've already centered working memory. So this column, working memory centered, is just the score on the working memory task minus the mean of that column. I've also, again to save time, already created the dummy codes, and you'll see those correspond to the two threat conditions. So D1 is dummy code corresponding to threat 1, and D2 corresponds to threat 2. Okay, so the first thing I'm going to do is just look at some summary statistics. And since we have an important conditional variable here, the name condition, I'll do describe by, and we'll do describe by condition. And here's the output. And you'll see that we really, these are made up data, and we really exaggerated the effect of stereotype threat. So here you'll see the mean of IQ is 52, the mean of IQ is 48. We did that just to make this effect really clear and to make the moderation effect really stand out. It's unusual that you would get an effect this strong in a real stereotype threat experiment. This is just done for illustrative purposes. Okay, so before we do the moderation analysis, you might want to ask, well, was that effect of stereotype threat significant? Certainly looks so, right? But we could test that. And we could test that a couple of ways. First, I'm going to do it the only way that you would know how at this point, because we've only done correlation regression. So you would have to do a model that I'm calling model 0 with IQ as the output variable and then the dummy codes as the predictors. And so if I run that model, you'll see that the overall model R squared is about 67%. This is, again, a really big effect, much bigger than you would expect in a real experiment. And this F value is significant. And what these values tell me is that the difference between control and threat 1, which is right here, so that's the difference between the control group and threat 1 group, is a drop of almost 45, 46 intelligence points, or IQ points. And then in condition 2, a drop of about 50. Again, this is exaggerated. But this is saying each of those effects are significant and the overall model is significant. So yes, the effective stereotype threat is a significant effect. And here are the confidence intervals. Again, very large effects. Again, we did this just to make it clear. Let's go back to the script. What we'll do in a couple of weeks is we'll start doing analysis of variance. And that's the way that we would typically analyze these data if all we were looking at was just the effective stereotype threat. So if we just have an experimental variable, a condition variable that's categorical, and a continuous outcome like IQ, then we could just do an ANOVA using this AOV function. And then to do the pairwise comparisons, we do what's called a post hoc test. And the most common one of those is called a Tukey test, named after the statistician John Tukey. And we'll talk a lot about this in the analysis of variance segment, but I just wanted to show it to you now. So let me run that. To show you that we get pretty much the same output with a slight difference. So you see here what the AOV function gives you is it gives you an overall F value and a P value for that overall model. And you see that this F value is the same thing that we got when we ran the LM function with those dummy codes, because it's the same thing. It's a general linear model. So the F value is the same. What Tukey's does is it gives us these pairwise comparisons. So control versus threat 1, is that difference significant? Yes. Here's the p-value. It's less than 0.00001 and so on. What it also does here, though, is it compares threat 1 to threat 2, and there's not a significant difference there. We didn't know that from the LM because we would have to change our referent group, right? There is one slight difference, though. If you've picked up on it already, then great. You may have noticed that the confidence intervals are slightly different. So they're slightly wider when we did the LM function than when we ran the Tukey function. Oops, excuse me. Let's go right there, right? They're slightly wider when we run the Tukey function. And that's because the Tukey test adjusts for multiple comparisons. So we're doing multiple pairwise comparisons here. And what that can do is inflate the probability of a type 1 error. So that's what the Tukey test was designed to do, to adjust the p-value and adjust the standard error so that we control for this inflation of type 1 error. So that's why they're slightly wider when we do the AOV function. Just wanted to point that out to sort of preview where we're going with analysis variance. Now let's get back to the script and do our moderation analysis. So in the moderation analysis, the first thing I'll do is run model 1, which just gives what I call the first order effects. So this is just the effect of working memory on IQ and the effect of stereotype threat on IQ. If we run that model, we already knew that the effect of stereotype threat is significant, and now we see that there's also a significant relationship between working memory and IQ, which is true of lots of published research. So we have a significant relationship there. So these are just the first order effects. What we want to know in moderation is, do these two variables interact? So does working memory moderate the effect of stereotype threat? So to do that, first before I do that, I want to show you a plot of just the main effect. So that's the first order effect of working memory on IQ. You can see there's a positive relationship. But if you look, it looks like there's a lot of suppressed values on IQ, right? That's what we're going to see in a moment when we run the moderation. Okay, so now let's run the moderation analysis. We need to create two more predictor variables, and they're the product of the working memory score times the dummy code. So I'm just going to do this all in one step because this is going to be a long lab. Let me run all of that. So I created the two new variables. Here they are. And here they are in the output. and you see that both are significant. So what this is saying, what these values are the difference in slope between the threat 1 group and the control group, and the difference in slope between the threat 2 group and the control group. And what this is telling us is each of those are significant differences. And if you look at the R-square, we're now accounting for even more variance in the model than we were with model 1. Now, is that change in R-squared significant? We can just use the ANOVA function, and we see that indeed it is. So this is evidence that working memory does indeed moderate the effect of working memory. So let's go back to the script. I could then look at the scatter plots to illustrate this effect, and I commented out the scatter plots by group, but you could run those if you like. I just want to show you the second part of this. And there it is. Let me make that larger. So here are the threat 1 and threat 2 groups down here. They're in blue and green. And you see what's happened here is the IQ scores are sort of suppressed in this condition, especially for people on the lower end of the working memory scale. Right? For people on the higher end of the working memory scale, they're not really as affected by the stereotype threat manipulation. So what this looks like is working memory moderates the effect of stereotype threat in the sense that if you have a high working memory to begin with, then you're not going to be as affected by that threat manipulation than if you are on the lower end of the IQ scale, then you're really impacted by that stereotype threat manipulation. So that's really nicely illustrated here in this graphic using ggplot2. Okay, so let's move on to segment 2. In segment 2, I'm going to use a different data set, and we're going to test for mediation. So notice this is just called stats1.13.lab.7b. We're using a different data set. Now there's just control and a threat group. There's just one stereotype threat group. And I just have IQ and working memory. No need to center it. I can get the summary statistics. And what we see here is it looks like there's just a drop in both IQ and working memory, a slight drop. So the reason we downloaded the multi-level package was because there's a function in there called Sobel. And if you know from the lecture, that's the Sobel test the indirect effect, right? But that function actually runs the whole mediation analysis for you. But I wanted to illustrate it with the three LM functions and then show you that the Sobel function will give you the same thing. So let's first run it with these three LM functions. I need to go back up a little. So here's the first model. I called it model YX because I'm just testing the direct effect. So that's just the direct effect of condition on IQ, and that's significant. So that's telling us that this 11-point drop in IQ as a function of stereotype threat, that it's significant. I then ran a model that I called YXM. That's the full model. And you'll see that the stereotype threat effect is now no longer significant. And the effect of working memory is significant. And the last piece of the puzzle is just, does the predictor variable condition, does it predict working memory? And yes, it does. So that drop in working memory, that was also significant. So this is evidence for mediation. You can do that all in one step, it turns out. And here are the results. You see that the Sobel function, if we just put in X, the mediator, and Y, in that order, separated by commas, then it will give us the output for all of the regressions, and it will give us the magnitude of the indirect effect, and it will give us the z-value of the Sobel test. So a z-value of negative 3.87, that's significant. What you need in a two-tailed test is 1.96, and in a one-tailed test, around 1.65, I believe. And those correspond to p-values of around 0.05. So that's telling us that this is significant. Okay, and that's the end of that script. That's the end of this lab. That's all you'll need to do the next assignment. I'll talk to you next week.